Hello everyone, welcome back to the channel. In today's video, we're diving into a topic that often comes up in Python interviews classes. Understanding how to work with classes, object-oriented programming, and various class features is key to nailing Python coding interviews. We'll be exploring practical questions and examples that will help you master the concepts behind classes, inheritance, constructors, and more. So if you're prepping for an interview or just want to deepen your understanding of Python classes, you're in the right place. Uh, Class in Python is like a template or blueprint that helps you create objects. Think of it as a plan that outlines the characteristics, attributes, and actions methods an object will have. When you define a class, you're basically saying, here's what my object will be able to do and what kind of data it will hold once the class is defined. You can create multiple objects based on that plan. One of the great things about classes is that they support inheritance, meaning one class can take on properties and behaviors from another class, which makes your code more efficient and reusable. In Python, classes are an important part of object-oriented programming (OOP), helping you organize and manage your code in a way that's easier to understand, maintain, and expand as your program grows. Let's jump into some practical Python class examples to get a clear understanding of how they work. We'll explore how to create a class, define its attributes and methods, and then use those to build objects. Through these examples, you'll see how classes make it simple to structure and organize code, allowing you to create multiple objects based on the same class blueprint. We'll also explore concepts like inheritance and method overriding, which let us reuse and customize code efficiently. So get ready to see Python classes in action with straightforward hands-on examples. 1. Basic class with methods. Question: write a Python class person that has two attributes, name and age. Add a method greet that returns a greeting message using the person's name. The person class in Python is a simple example of how to define and use classes in object-oriented programming. The class begins with the underscore underscore init method, which is a special method that acts as a constructor. It automatically gets called whenever a new object or instance of the class is created. In this method, the parameters name and age are passed in when creating a person object, and these values are assigned to the instance variables sense.name and self.age. The keyword self refers to the current instance of the class, allowing each object to store its own unique data for name and age. The class also contains a method called greet, which is a regular function inside the class. This method uses the instance's name attribute accessed via self.name to return a greeting message like hello. My name is Alice. The method provides a simple way to interact with the data stored in the object. When an instance of the person class is created, such as person Alice, 25 the underscore underscore init method initializes that specific object with the name Alice and the age 25. Then, calling the greet method on this instance, i.e. person.greet, will return a personalized greeting using the name attribute of that instance. This example demonstrates how classes encapsulate both data attributes like name and age and behavior methods like greet into reusable structures that can be instantiated multiple times with different values. 2. Class with inheritance. Question: write a Python class employee that inherits from a person class. Add an additional attribute salary and a method get underscore details to return the employee's details. In this example, we have two classes, person and employee. The person class is the base class, which defines two basic attributes, name and age. These attributes are initialized using the underscore underscore init method, which is called whenever an instance of person is created. The employee class inherits from the person class, meaning it can access the name and age attributes from the parent class. However, the employee class adds its own unique attribute, salary, making it more specialized. In the employee class, we use super dot underscore underscore init name age to call the underscore 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 init method from the person class. This is crucial because it allows us to reuse the logic for initializing the name and age attributes, preventing code duplication. Once the name and age are set, the employee class assigns its own attribute salary, making each employee instance complete with all three attributes. The employee class also has a method called get underscore details or bkels, which formats and returns a string containing the employee's name, age, and salary. This method demonstrates how we can create specific behaviors in subclasses that use the inherited properties from the base class. When we create an instance of employee, for example, employee equal to employee Bob 30 50,000, it sets Bob's name, age, and salary. Calling employee dot get underscore details returns the formatted details: employee name Bob, age 30, salary 50000. This example showcases how inheritance allows us to build on existing code. The employee class inherits the general characteristics of a person but adds its own details, demonstrating how we can reuse and extend functionality in an organized and efficient manner. 3. Encapsulation with private attributes. Question: write a Python class bank account with private attributes balance and account underscore number. Add methods to deposit and withdraw money, ensuring the balance cannot go negative. In this bank account class, we're simulating a basic bank account system with functionality for depositing, withdrawing, and checking the balance. The class has two main attributes: underscore underscore account underscore number and underscore underscore balance. These attributes are marked as private by using double underscores underscore underscore or underscore, which means they cannot be accessed directly from outside the class. This is a way to encapsulate the data, ensuring that account details and balance are only modified through the methods provided by the class. The underscore underscore init method is a constructor that initializes the account when it is created. It takes an account underscore number as a parameter and sets an initial balance which defaults to 0 if no balance is specified. The class provides a deposit method that allows users to add money to the account. When called, it increases the balance by the specified amount. The withdraw method enables users to withdraw money from the account. Before withdrawing, it checks if there are enough funds by comparing the requested withdrawal amount with the current balance. If there are sufficient funds, it deducts the amount from the balance; otherwise, it prints an insufficient funds message to indicate that the transaction cannot be completed. To check the current balance, the class has a get underscore balance method which returns the value of the private underscore 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 balance attribute. Since the balance is private, this method provides control access to it. In the test section, an instance of the bank account class is created with an account number and various operations are performed: depositing 1000 units, withdrawing 500, and then checking the balance, which prints 500. This class design demonstrates the principles of encapsulation, where the internal state of an object is hidden and managed through public methods, ensuring controlled interaction with the object's data. 4. Polymorphism with method overriding. Question: write a Python class shape with a method area. Create two subclasses rectangle and circle that override the area method to calculate the area of a rectangle and a circle respectively. In this example, we are exploring the concept of inheritance and polymorphism in Python through the shape, rectangle, and circle classes. The shape class acts as a base or parent class. It defines a general structure for all shapes but doesn't implement any specific behavior for calculating the area. The area method in the shape class is a placeholder using pass, which indicates that the method will be overridden by any subclass that inherits from shape. This design allows us to define different types of shapes later, each with its own specific way to calculate the area while maintaining a consistent interface, the area method. The rectangle class is a subclass of shape. It adds its own attributes width and height and overrides the area method to calculate the area of a rectangle using the formula width height. When we create an instance of rectangle e.g. rectangle 5, 3, it stores the width as 5 and the height as 3. When the area method is called, it multiplies these two values to give the rectangle's area of 15. Similarly, the circles also inherits from shape. It has its own attribute, radius, and its version of the area method calculates the area of a circle using the formula pi multiplied by the radius squared. When we create an instance of circle e.g. circle 4, the radius is set to 4, and calling area computes the circle's area using pi multiplied by 4 squared, which is approximately 50.27. This structure demonstrates the power of inheritance in object-oriented programming. Both the rectangle and circle classes share the same interface, the area method, but implement it differently based on the specific shape. This allows for code reuse, clarity, and flexibility, as the base class shape provides the general framework while the subclasses rectangle and circle define the details of how each shape calculates its area. 5. Class with class methods and static methods. Question: write a Python class calculator with a class method that adds two numbers and a static method is underscore positive to check if a number is positive. In this calculator class example, we explored the use of class methods and static methods which allow us to perform operations without needing to create an instance of the class. The class method add is defined with the add class method decorator, which means it is associated with the class itself rather than an instance of the class. The class parameter refers to the class and is used when you need to interact with class level data or methods. In this case, we don't use class directly, but it still allows us to call add using the class name calculator dot add 10, 20 instead of creating an object. The method simply returns the sum of two numbers, demonstrating how class methods can encapsulate behavior without being tied to specific instances. On the other hand, this underscore positive method is marked with a static method. Static methods don't rely on either class level class or instance level self data. They are self-contained and perform tasks that are related to the class but don't need access to its attributes or methods. Here, this underscore positive method checks whether a given number is greater than 0 and returns true or false. Static methods are ideal for utility functions like this, which logically belong to the class but don't need any internal data. By using both class and static methods, we can perform operations like adding numbers or checking if a number is positive directly through the calculate class without the need to instantiate objects. This approach simplifies code, especially when there's no need to store state or data, making it both efficient and easy to read. 6. Operator overloading with magic methods. Question: write a Python class vector that supports vector addition using operator overloading with the add magic method. In this vector class example, we're demonstrating the power of operator overloading and how it can make working with custom objects more intuitive in Python. The class represents a 2D vector with x and y components. When we create an instance of vector, the underscore underscore init method is called initializing the vector with the given x and y values. For example, v1 vector 2, 3 creates a vector with x2 and y3. The underscore underscore add method is where the real magic happens. By overloading the operator, we make it possible to add two vector objects directly using v1 plus v2. Under the hood, Python calls the underscore underscore add method, which takes another vector as input other, adds the corresponding x and y components, and returns a new vector object with the sum components. In our case, v1, v2 results in a new vector with x equals 2 plus 4, which equals 6. And y equals 3 plus 5, which equals 8. To make the output readable when printing a vector object, we define the underscore underscore string method. This method tells Python how to represent the vector as a string, so when we call print v3, it outputs a friendly format like vector 6, 8. Without this method, printing the vector would display the object's memory location, which isn't helpful. Overall, this example showcases how operator overloading in Python can simplify working with custom objects like vectors by making the syntax clean and more natural. It allows us to perform arithmetic operations like adding vectors in a way that feels intuitive, just as we would with built-in types like numbers. 7. Singleton design pattern. Question: write a Python class singleton that ensures only one instance of the class can be created. In this example, we are implementing the singleton design pattern, which ensures that a class has only one instance and provides a global point of access to that instance. The singleton class is designed so that no matter how many times it is instantiated, it always returns the same object. To achieve this, we override the underscore underscore new method, which is responsible for creating new instances of a class in Python. Inside this method, we use a class level attribute underscore instance to store the single instance of the class. Initially, underscore instance is set to none, indicating that no instance has been created yet. When underscore underscore new is called, the code checks if underscore instance is still none. If it is, the method creates a new instance by calling super dot underscore underscore new class, which is the standard way of creating an object in Python. This new instance is then stored in underscore instance. If the class is instantiated again, the underscore underscore new method will return the existing underscore instance rather than creating a new one. This ensures that only one instance of the class exists throughout the lifetime of the program. In the test section, we create two variables, s1 and s2, both of which attempt to create new instances of the singleton class. However, due to the singleton pattern, both variables end up referencing the same instance. When we check S1 is S2, it returns true, confirming that Swan and Steve are not separate objects but point to the exact same instance. This behavior ensures that the class follows the singleton pattern, making it useful when you need to control the creation of objects and ensure only one instance is used, such as for managing connections, configurations, or shared resources across your program. 8. Class with inheritance and multiple inheritance. Question write Python classes bird and mammal both having a method move. Create a subclass bat that inherits from both classes and overrides the move method. In this example, we are demonstrating multiple inheritance in Python where the bat class inherits from two parent classes, bird and mammal. Each of these parent classes has its own move method. The bird class's move method returns flying, representing the movement characteristic of birds, while the mammal class's move method returns walking, which is typical for mammals. The bat class, however, represents a unique case in the animal kingdom. Bats are mammals, yet they can fly like birds. To reflect this dual capability, the bat class overrides the move method and returns a new string flying and walking. This customization allows the bat class to define its own behavior despite inheriting from both the bird and mammal classes. When an instance of bat is created and its move method is called, the Python interpreter uses the method defined in the bat class, even though bat inherits from both parent classes. This shows the principle of method overriding, where a subclass can provide a specific implementation for a method that is also present in one or more of its parent classes. The bat class's move method demonstrates how multiple inheritance allows a class to inherit characteristics from multiple sources while still being able to customize or override behavior to suit its specific needs. 9. Class with property decorators. Question write a Python class temperature that stores a temperature in Celsius and uses a property decorator to calculate the temperature in Fahrenheit. In this example, the temperature class demonstrates how we can use properties in Python to create an intuitive interface for accessing calculated values. The class is initialized with a temperature in Celsius, which is stored in the private attribute underscore Celsius. The underscore indicates that this attribute is meant to be protected from direct access outside the class, promoting good encapsulation practices. The real magic happens with the Fahrenheit property, which is defined using the @property decorator. This allows the Fahrenheit method to be accessed like an attribute, even though it's performing a calculation under the hood. When you access temp.Fahrenheit, Python automatically calls the method and returns the Fahrenheit equivalent of the stored Celsius value. The conversion is done using the standard formula for converting Celsius to Fahrenheit: Celsius multiplied by 9 divided by 5, then add 32. The benefit of using a property here is that it makes the class easier to use. From the user's perspective, accessing the Fahrenheit value is as simple as accessing any other attribute temp.Fahrenheit without needing to explicitly call a method. This approach also allows the class to encapsulate the conversion logic, keeping the implementation hidden while providing a clean, intuitive interface for users. Overall, this structure enhances code readability and provides a more natural interaction with the class. 10. Abstract class example. Question write an abstract class vehicle with an abstract method max underscore speed. Create two subclasses car and bike that implement the max underscore speed method. In this example, we are using an abstract class vehicle to demonstrate the concept of abstraction in Python. The vehicle class is defined as an abstract base class ABC by inheriting from the ABC module, which allows us to define abstract methods. An abstract class serves as a template for other classes and cannot be instantiated on its own. Instead, it enforces that any class inheriting from it must implement the abstract methods defined within it. In this case, the max underscore speed method is marked as abstract using the @abstract method decorator, meaning any subclass of vehicle must provide its own implementation of this method. The car and bike classes inherit from the vehicle class and are required to implement the max underscore speed method. In the car class, the method returns a maximum speed of 200, and in the bike class, it returns 150. This ensures that both subclasses define how the max underscore speed method behaves, specific to their context, while adhering to the structure laid out by the abstract base class. When testing, we create instances of car and bike and then call their respective max underscore speed methods. Each subclass returns its own version of the maximum speed, which is 200 for the car and 150 for the bike. The power of abstraction here lies in how it enforces structure across all subclasses, ensuring that any vehicle class derived from vehicle must have a max underscore speed method but allows each subclass to customize the implementation according to its needs. This makes the code more organized, modular, and scalable as new types of vehicles can be added later with their own specific behaviors, while maintaining the overall structure defined by the abstract base class. 11. Multiple inheritance example. Question: write a Python class person and employee both having a method details. Create a class manager that inherits from both and demonstrates multiple inheritance. In this example, we explore multiple inheritance in Python using the person, employee, and manager classes. The person and employee classes each define a method called details that turns a string either person details or employee details depending on which class is called. These methods represent generic details for a person or an employee. The manager class inherits from both person and employee, demonstrating multiple inheritance. Even though both parent classes have their own versions of the details method, the manager class overrides this method with its own implementation, which returns manager details. This shows how Python allows subclasses to define their own specific behaviors even when inheriting from multiple parent classes. When the manager class is instantiated and its details method is called, the overridden version in manager takes precedence and the method prints manager details. This example highlights Python's method resolution order Maro, which ensures that when a method is called on a class that inherits from multiple classes, the most specific method, in this case the one defined in manager, is used even if the parent classes define methods with the same name. This structure allows for flexibility in defining unique behaviors for subclasses while still leveraging multiple inheritance. That's it for today's video on Python classes. I hope these practical examples gave you a better understanding of how to work with classes and object-oriented programming in Python. These concepts are foundational and often show up in interviews, so practicing them will definitely help you feel more confident. Don't forget to like this video if you found it helpful, subscribe to the channel for more interview tips, and hit the notification bell so you never miss an update. Thanks for watching, and I'll see you in the next video.